All right, Algebra 1A students, welcome to part 2 of lesson 6.4. We're going to continue in this video talking about applications of linear systems or applications of systems of equations. The type of problem we're going to look at today is about speeds going with or against some kind of wind or river current or something that's either going to help or hurt our speed. So when we are, let's say, flying an airplane or rowing a canoe up a river or down a river, the speed of the wind or the current is going to affect the speed that we're actually traveling at, regardless of how fast, an airplane thinks it's going or how fast a canoe paddler thinks they're paddling. The river current or wind speed is going to affect, either helping or hurting, that overall speed that we're moving at. So when we're working with the wind or with the river or whatever, the two speeds are actually going to get added together. Airspeed here just means your speed. So basically what you're doing is the speed plus the wind is going to get you the overall speed. And when you're working against each other, when you're trying to fly into the wind or when you're trying to paddle up a river, meaning against the river current, the two speeds are going to work against each other. So your speed is going to be subtracted by the speed of that wind or the speed of that current. Okay, so this is going to help us set up systems of equations that are going to be very easy to solve by elimination. Here's an example of what that might look like. So I have here this scenario. You row a canoe upstream at a speed of 2 miles an hour. You can travel the same distance downstream at a speed of 5 miles per hour. What would your rowing speed be in still water, meaning no current, no river current helping or hurting you? And then what is the speed of that current that's either going for you or against you? Okay, so this scenario is actually quite easy to solve with a system of equations. What we have to understand is when we are rowing upstream, the two speeds are working against each other. So the speed of my canoe is being subtracted by the speed of the river. Okay? And in the end, you can see here that my upstream speed is 2 miles an hour, so equals 2. Okay, equals 2. And then, of course, my canoe speed plus the speed of the river, meaning they're working together, that means I'm going downstream because they're working together. So upstream means minus, downstream means plus, just to be clear. And I'm told that my speed going downstream is 5 miles an hour, so I'll do C plus R equals 5. And now this is a system of equations that you and I can solve with elimination very easily, because if you look at the R's, one's a negative 1R and the other's a positive 1R. That's the same, so I can just eliminate those by adding these two equations together. Right? Add those two equations together. C plus another C makes 2C equals 7. So the speed of my canoe in still water would be 3.5 miles per hour. Right, so my canoe speed is 3.5, and if I also want to find the speed of the current, meaning the speed of the river, and the speed of the river is R, so if I plug the C value back into here, into here, or into there maybe is easier, what I end up with is 3.5 plus the speed of my river is equal to 5, and I can solve that for R pretty easily by simply subtracting 3.5 minus 3.5 and I get that the river speed, R, is equal to 1.5 miles per hour. So the speed of my current is 3.5, the speed of the river, the speed of my canoe is 3.5, the speed of the river is 1.5. So once we have these kind of speed equations set up, the elimination is very easy, going back to some of the early ones that we did in this chapter. If you have questions about upstream versus downstream, working together, working against, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.